everyone and welcome to the course Introduction to Algebraic Graph Theory. There is a saying that beautiful mathematics eventually tends to be useful and useful mathematics eventually tends to be beautiful. This course is a neat example of it. There are many applications of this course in various branches of science and engineering, including the emerging ones like AI, ML and quantum computing. So what is this course about? This course is about two things. On one hand, we have graphs or networks. There are many examples of graphs or networks around us. For example, our social networks like Facebook, Instagram, Twitter, X. Then we have transportation network like railway network, road network. Then we have biological networks like protein interaction network, and this internet through which you are watching this introduction of course, and you will watch my lectures. And on the other hand, we have matrices, the matrices associated with these graphs or networks. For example, the adjacency matrices, the incidence matrix, the Laplacian matrix, the signless Laplacian matrix, and many more. But what we are looking for? We are looking for the answers of the questions related to the structure of these graphs or networks. For example, whether these graphs are connected. If at all they are connected, how well connected they are. What is the size of largest community inside any graph? How many spanning trees are there? What is their click number? What is their independence number? We will be answering all these questions using the help of matrices. In particular, we will try to make use of the eigenvalues, eigenvectors, the rank, the determinant of these associated matrices. Okay. Now let me give you three main reasons why one should opt for this course. The first reason is quite obvious. Irrespective of branch of science or engineering you are studying in, you must have encountered various phenomena, various systems which can be easily modeled in terms of graphs or networks, and one has to study them. The second reason is this course is heavily laden on the study of symmetric matrices, and these matrices are everywhere. Moreover, these matrices display extremely beautiful properties, and as I said in the beginning, beautiful mathematics eventually tends to be useful. So these matrices has lots and lots of application in various analysis. The third reason is specifically for the students who belongs to computer science or mathematics. There are many graph structures, many graph properties which are computationally challenging to find. There is no fast algorithm for such questions. More formally, there is no polynomial time algorithm, and most likely there will not be any. There is a very famous conjecture in computer science and mathematics which is open since more than 50 years, and there is a $1 million prize on this question. The question is whether P equal to NP or not. Let us not go into detail of this question, but it says that if there is any polynomial time algorithm for any of the questions I stated just now, the conjecture will be solved and P will be equal to NP, and the life will be very simple, but the hope is very less. But how the algebraic graph theory can help us? The eigenvalues or sometimes the ranks can give us a very nice bounds on these very challenging questions. Okay. So till now I have given you a very beautiful picture of algebraic graph theory, a very optimistic picture, okay. But are there some limitations of algebraic graph theory? Can eigenvalue determine everything about the graph? Can it tell every story about the graphs? Or more precisely, can eigenvalues determine the graph? to know the answers of all these questions, you have to watch my video lectures. And regarding the prerequisite for this course, if you know basic linear algebra, little bit of graph theory, you are most welcome to opt for this course. I will try to make this course interesting, try to make this course very easy to understand. Okay, now let us go to the course content and outline of this course very briefly. So this is a 8-week lengthy course. Week 1, we will start with finding the number of spanning trees in a given undirected graph, and it is also known as matrix tree theorem. It's a very beautiful application of determinants of some matrices of incidence matrix and Laplacian matrix. So if you know just 11th or 12th class mathematics stuff, it's very easy to understand. Then we will talk about the number of connected component in a given graph using the rank of these matrices. Week 2, we will start with first the rank of 0, 1 incident matrix, which can actually determine whether the given graph is bipartite or not. Then we will introduce two very famous concepts in linear algebra and matrix theory: the eigenvalues and eigenvectors. Very beautiful, very useful. Okay, then we will talk about the spectral theorem, which says that every symmetric matrix has n orthogonal eigenvectors, and it's a very useful fact. The immediate use that we will do it, we will find the number of walks of arbitrary length in a given graph, and this theorem also help us in finding the matrix power of any symmetric matrix very quickly. Okay, week 3, we will first start with a bound or diameter of a graph. Then we will head towards one of the most famous theorem in linear algebra. The theorem is Cauchy-Interlake theorem. Very application. There are many applications of this theorem. Okay, and we will see where towards the end of this course. Okay, so and then we will calculate the eigenvalues and eigenvectors of some well-known graphs. Okay, week 4 will be devoted to another beautiful theorem in matrix theory that we call Perron-Frobenius theorem. This theorem is about the non-negative matrices, but we will focus on non-negative symmetry matrix because we have to deal with symmetric matrices in this course. Okay, then we will see that just by knowing the eigenvalues of a graph, we can actually determine whether the graph is bipartite or not. Okay, very powerful, beautiful result. Okay, then we will find bounds on chromatic number and clique number of graphs. Okay, and remember that these two quantities are extremely challenging. There is no polynomial time algorithm for these questions, but the eigenvalues will give some very easy bounds on it. Week 5, we will introduce very simple looking, very beautiful looking graphs. The graphs are regular graphs, then strongly regular graphs. Then we will see one of the famous theorem in 1960s. The theorem is Friendship theorem, and we will try to prove this theorem using the properties of strongly regular graphs. Okay, then we will give a bound on the independence number of regular graphs. Week 6 is kind of limitations of algebraic graph theory. It says that two graphs may be non-isomorphic, but they can still have the same eigenvalue. So it says that the eigenvalues may not determine the graph. Okay, so this is kind of some limitation of algebraic graph theory. Okay, then we will move ahead with a very famous conjecture which was proved very recently, and the conjecture is sensitivity conjecture. The proof is very cute, very simple using the eigenvalues, but this problem was open since last 30-40 around more than 30 years. Okay, week 7, we will now cover some advanced topic in algebraic graph theory like expanders graphs and Ramanujan graphs. There are many applications of it, and we will try to find some construction of it using two lifts, using zigzag products. Then we will talk about the Cheeser's inequality, the expander mixing lemma. Okay, In the last week, we will talk about the algebraic connectivity and the Fiedler vector, which says that how well connected a given graph is. Okay. Then we will talk about sine graphs, where the edges can have positive weights or negative weights. Okay. Then finally, we will calculate determinant and then permanent. Remember, the determinant, very easy problem to compute using our computers, but there is no polynomial time algorithm for permanent. Very again a challenging one. Okay, but we will calculate both of these quantities with the help of the graph. We will first represent a matrix in terms of graph, then we will see graph structure and try to find these quantities. Okay, very good. So this was brief outline about this course. So many exciting things are ahead of us. Okay, so I hope you will opt for this course. Okay, so thank you very much and see you in my lectures.